Kinematics. There are many equations for kinematics, and they go as such. Velocity is equal to the initial velocity plus acceleration times time. Distance subtracted by initial distance is equal to half of velocity plus initial velocity times time squared. Distance minus initial distance is equal to half of acceleration times time plus the initial velocity times time. And finally, velocity squared is equal to the initial velocity squared plus 2 times acceleration times distance minus the initial distance. There are many ways to remember these equations and which one to use, but the main one goes as such. The first one has no distance, the second one has no acceleration, the third one has no final velocity, and the fourth one has no time. Now, look at this funny video.
5.
Here's a distance time graph for said video of the water balloon. As you can see, as time increases, the velocity of the balloon decreases until it reaches the distance of the balloon increases at a decreasing rate until it reaches a stable distance upon contact with Adam's head. Now let's make a little problem for it. We're going to find acceleration for it. So here's the word problem. Atom is domed by a water balloon that travels 3.96 meters in 0.327 seconds. What is said acceleration of the balloon? So let's get our variables first. We know that we're finding acceleration, so we're going to put a question mark for that. We also know that both initial velocity and initial distance are equal to 0. We know that our distance is 3.96 meters and our time is 0.327 seconds. We also know that we don't have any velocity, so we're not going to put anything for that. So we're going to use this formula as it has no final velocity in it. We're going to plug the numbers in, then we will subtract the 0 from 3.96 and multiply the 0 with 0.327 immediately, and then we'll square 0.327. Then we will multiply 1.1069929 by 0.5 and get 0.0534645 as the answer. And then we will divide that from 3.96 to get acceleration, which comes out to 74.1 meters per second squared. Alright, so here's a video of an egg dropping on Adam's head.
5.
3, 2, 1.
So here's the graph for that. We'll do it in velocity. So as you can see, until the egg keeps on going down at a constant rate until it reaches terminal velocity, at which point it just stays there. And then we will make an equation for velocity. So the equation is an egg is dropped on Adam's head at a speed of negative 9.81 meters per second squared from rest at a distance of 2.44 meters. What is the final velocity of the egg? So let's get our variables. We know we're finding velocity, so we're going to put a question mark for that. We know that both initial distance and initial velocity are equal to 0. We know that our distance is 2.44 meters, and we know that our acceleration is negative 9.81 meters per second squared. We also know that we don't have time, so we won't fill that one in. So we'll use this equation because it doesn't have time. We will plug our numbers in, then we will square the 0, multiply the 2 by negative 9.81, and subtract the 0, giving us negative 19.62 times 2.44. So we will multiply those, and then we will square them, putting the negative sign temporarily away because you can't square root a negative. And the answer comes out to negative 6.92.